Okay, in this video we turn to the derivative of the tangent function. We've talked previously about derivative of sine and cosine. We've talked previously about derivative of sine and cosine. We developed both of those using our limit definition. We could try to use our limit definition for tangent. We could invoke that and see what happens, right? Limit as h goes to 0, tan x plus h minus tan x. We could put that together and see what happens using the angle sum formula for tangent and, see where that gets us. But we have another option now that we have the quotient rule. Now that we have the quotient rule, we can rewrite tangent x as the derivative of sine x over cosine x. So the derivative of tangent is really just a quotient. And for that problem, we need to recall, of course, and remember that the derivative of sine is cosine, and the derivative of tangent is negative sine. Derivative of sine x is cosine x, and the derivative of cosine is negative sine. So as we approach this problem, this time I'm not going to write out all of the detail as I've done in some of the other examples. So that's going to be cosine x times the derivative of sine. Right, bottom function times the derivative of the top, and derivative of sine is cosine, minus the top function, sine of x, times the derivative of cosine, which is negative sine x. And then that's all going to be over the bottom function squared. So all of that over cosine squared. And then let's go through and do a little bit of simplifying. Cosine times cosine is cosine squared. Sine minus sine times negative sine is going to be plus sine squared. Now you might have some different thoughts about where we could go here. Right, where we could go here. We could do cosine squared over cosine squared plus sine squared over cosine squared. That's perfectly fine. That's perfectly fine. Or we can remember our numerator there, cosine squared plus sine squared. If you don't remember any other identity from trig, hopefully you remember this one. The cosine squared plus sine squared is 1. And we get 1 over cosine squared, which is a perfectly fine answer, but traditionally we recognize that as being secant squared. By the way, if we had taken this cosine squared and divided it by cosine squared, that would be 1. And then sine squared over cosine squared would be tangent squared. So we would get 1 plus tangent squared. And of course, 1 plus tangent squared is another identity. That's equal to secant squared. But traditionally with tangent, we say the derivative of tangent is secant squared. Although you could say it's 1 plus tangent squared because of that identity. So there's the derivative of tangent x. In one of the homework turn-in problems, I'm asking you to do the derivative of cotangent x, and it follows a very similar pattern.